Okay, in this video we are going to look at one more type of question here. So what is happening is that electron moving with a speed of is enters a uniform electric field midway between two parallel plates. So let me draw the diagram here. I think it will be more clear here. So suppose these are my parallel plates. This is one and that's the other one here. We got two parallel plates here, and it's an electron moving, so we have positive charges here, let's say, and we have this plate is negatively charged, and the electron enters here. So electron enters here, it's electron, and what happens is that this electron, as it enters the electric field at this point, and then we got this positive plate here, so electron will feel a force of attraction towards the positive plate. So as long as this electron is between these two plates, it will move vertically. Let's say it will move towards the positive plate, and then it exits the plate like this. So what is happening is when it exits the plate, when it comes out of these two plates, it gets vertically deviated by this much amount. If there were no electric field, it will go straight like along this dotted line, but because of this positively charged plate here, the electron will get deviated from this line. And our question is asking you to find this distance, this S here. Now what else is given? That the distance between plates is 0.5 centimeter, right? And the plates are, this plate is at plus 200 volt, negative plate is at lower volt normally, is always. This is plus 200 volt here, and the plate length is 20 centimeters. Okay, so first thing we need to find this, we are trying to attempt part A of the question here. Find the time the electron is between the plates. So we see that this question is very similar to projectile motion question. The plate length is 20 centimeter, which is, let's say it is horizontal distance. So when the electron needs to complete 20 centimeter of horizontal distance, and it will do that only with the horizontal velocity. So it's a very simple question here. We got horizontal velocity of electron, which is 9 times 10 to the power 7 initially, and this velocity, horizontal velocity, does not change because there is no acceleration. There is no acceleration there. Why? Because electron is only experiencing a force in vertical direction. Force is only in that direction. Just like projectile motion, the gravity is always there. This is just like gravity, but horizontal component remains as it is because there is no force acting in the horizontal direction, and therefore no acceleration in the horizontal direction. So it's a very simple question for part A. What we have here is we are considering horizontal motion. Initial velocity is horizontal acceleration is 0. Horizontal distance that needs to be covered is 20 centimeters, which is equal to 0.2 meters, and I need to find time that it will take. Simple, I'll just use S equals to ut plus half at square. A is 0, so this thing becomes 0. S is equals to ut, and that will give you T is equals to S upon U. Substitute the value. S equals to 0.2, U is equals to 9 times 10 to the power 7, and I come out with a time of 2.22 times 10 to the power minus 9 seconds. So the electron covers 20 centimeter distance in this much time, and when it covers 20 centimeter horizontal distance, it has cleared the plates and it comes out here. So electron remains between the two plates for this much time. Next part is we need to find the vertical deflection. Now, so the vertical deflection is S. So here we need to consider the vertical motion. Now we need to think here a little bit. To find vertical displacement here, we need vertical acceleration. Where would you find vertical acceleration? We don't have vertical acceleration, we need to calculate it, and we can find that with this formula. But do we have the force on the electron? No. How can you calculate the force on electron? Force is equals to Q times E. That's your force divided by M. That will give you the acceleration, vertical acceleration. But do you have the E? No, we do not have the E. Can we calculate? So, okay, instead of doing this, let's work step by step. So which means that we need to find F. Do we have F? No. How can we find F? We can find F as Q times E. And do we have E? No. How can we find E? We can find E as delta V upon D. Yeah. So first we will find electric field intensity between the plate. Once we have electric field intensity between the plates, we would be able to find the force on the electron, and then divide. Once we have the force on the electron, we'll be able to find the acceleration. All right, so let's first find E. Now delta V is the voltage difference between two plates. So positive plate is at plus 200, negative plate is minus 200. So the voltage difference between the two plates is 400. And D, we have D given here. D is equals to 0.5. Oh no, D equals to 5 centimeters. So I don't write that correctly. 0.05. So D is equals to 0.05 between the plates, and that give me an electric field intensity of 8000 volt per meter. So between these two plates, I got this much electric field intensity. Now I can find force on the electron. Just remember, this electric field intensity is vertical, in the vertical direction. Therefore, the acceleration of the electron, as long as it is between the plates, will always be vertical. So F is equals to Q times delta E. Q is not delta E, QE. Q is 1.6 times E is 8000, and that gives me a force of 1.28 times 10 to the power minus 15 Newton. 10 to the power minus 15 Newton. We got the force. Now we can find the acceleration of the particle, acceleration of electron, which is equals to F divided by M, which we get as, this is F, and that comes out to be 1.045405 times 10 to the power 15 meter per second square. Now it is a simple question. My electron is between the plates for this much time, and all this while it is getting accelerated in the vertical direction by this much amount. So I consider the vertical motion here. So what is initial vertical velocity? 0, because initially when particle entered the electric field here, it was only traveling horizontally. So U equals to 0. A is equals to 1.405 times 10 to the power 15 meter per second square. Then it underwent this much acceleration. It experienced this much acceleration only for this much time given here. And we need to find out in this much time how much distance, vertical distance, it will cover. So we have S is equals to, we know the formula, S equals to ut plus half at square, ut is 0 plus half 1.405 times 10 to the power 15 and then square, and that gives me S equals to 3.4623 times 10 to the power minus 3 meters, and I could also write that as 3.463 millimeters. So this will be the deflection of the deviation of the electron from its original path when it emerges out of the plates.